right, so for these first few, just do your best, see what you can remember. If you can't remember something, then look it up. But just start to kind of look over those names and make sure you're starting to feel semi-comfortable. So it just says name it. Okay, I can do that. We have 9, I'm gonna do some of the odd ones. 9n to the 4th plus 3n plus 1. And I say to myself, well, to name, I'm really looking for 2 things. I'm looking, we call it for the degree, which is the highest exponent. Hey, does anyone remember what we call something if it's to the 4th power? Remember the word quarter? We call it quartic. Quadrant. Good one. Quartic. Similar to quarter, so like have some little strategies to help yourself out there. And then we have 3 terms. So we call it generally a polynomial, but if we have 3 terms, we call it a trinomial. I feel like those ones aren't too bad to remember. It's monomial, binomial, trinomial, and then there's like no really extra words. So definitely look over those degree ones. So there's some other ones there. I'll have you guys try those. I'm not going to do even the other odd ones, so you're good. Just make sure you refer back to your chart and you are starting to remember some of those names. I'm not going to have a ton of naming. I think it'll either be like a multiple choice or 2, or maybe like a matching section for the naming. So you'll kind of have the names there, but you just want to know what's what. So that's the first thing. Then we have sum and difference. How exciting. You know what, I'm just going to go for the fancy one. Let's go to number 9. That has addition and subtraction, so we'll just kind of get it done in one problem together, and then you guys can try the other ones. So with addition and subtraction, we just want to, 1, stay organized. Let me just write mine out. Because I see addition right here, and then subtraction over here. Oh, golly, this is really long when you write it out. Okay. Here's what I usually do. If I'm going to organize myself first, I'm going to say, okay, we have addition here, and then we have subtraction there. You can try to kind of do it in one step. You can do 2 things at once, whatever works for you. What I'm going to do is I'm going to take care of that subtraction sign, because that's the one thing I can speak from experience here. So this is my 15th year doing this, that people always mess up. That's like the one little thing. So anytime I see subtraction, I automatically distribute the negative. 2 negatives make a positive, and then 2 negatives make a positive. Okay. Everything else, if it's just addition, you can just kind of bring it down. So I'm going to have 8 minus 5k squared. And then if I add all these, those just kind of stay the same. So basically, I'm just making one big old problem. The main thing with that subtraction, I like to do my signs first. Now I just say, well, I'm just trying to combine a bunch of stuff. I like to do things in standard form, so I don't need to rearrange it. So I start where the highest exponent is, which is right here. And I say to myself, is there anything else I can combine with that? And the answer would be no, because there's nothing else that has k to the 4th. So I'm going to put that term. When I think about a term, I think about the base with the exponent, the number in front, which we call the coefficient, and the sign stays with it. So that would be negative 8k to the 4th. That's just my first term. And I just like think, are there any k to the 3rds? No. Okay. Are there any k squareds? Yeah. I have 1 here, and I have 1 here. So let's combine those. Just be careful with signs. That's the big thing with addition and subtraction. Once again, you guys know how to add and subtract. Negative 5k squared plus 7k squared gives me 2k squared. Remember, when we add and subtract, we do not change exponents. That's the one thing I want you to remember. Add and subtract, the exponent stays the same. So I say, well, what would be next? Just k, right? So this is just k, or k to the 1st. And this is k. Okay, so those can be combined together. Just be careful. Negative 5 minus 7 would give me negative 12k. And last but not least, we got our constants. Constants are just regular numbers. So we have 8 plus negative 3 plus 3. Okay. There's a weird buzzer going on. 8 plus negative 3 is 5. 5 plus 3 is 8. and there we go. There's nothing else I can combine because nothing else are like terms. And that will be your final answer. Oh, it says make sure your answer's in standard forms. Never mind, I got excited. I thought it said name your answer. If we were naming it just to get used to them, that would be a quartic polynomial with 4 terms, but it doesn't ask you to name it, so just. So there's a few adding and subtracting before that, where you're just kind of doing one thing at a time. So stay organized, only combine things that are alike, pay attention to signs. That's the main thing with addition and subtraction. So right now, does anyone think they have any questions on that? Okay. I'm just gonna do one GCF one, and then I'll pick maybe like 2 out of the other ones. I mean, once you know how to do one thing, they're all pretty simple. Factor, the common factor, that's GCF, yep.
So if it's over 3 terms, it's just a
Polynomial with whatever terms. Yep, exactly, there's no fancy names. All right, so let's look. I guess it doesn't really matter which one we pick. I try not to make the numbers too big. I mean, 11, 72, 36, 81. I don't even. It's not divisible by 8, so it shouldn't be too terrible. So I'll try to keep it not bad, but you can always use a calculator. Try to find some factors, go from there. So I'm just going to look at 10. I'll just kind of keep it the basic one. When I say that we have a GCF problem, we're just saying, what do all the terms have in common? So this is a trinomial, there's 3 terms. What do they have in common? So I kind of do it in steps. I'll do the numbers first. I have a negative 20, a 14, and a 10. Those would just be 2, right? Divisible by 2. Okay, that was exciting. And then I look at my base, and I say, I have m to the 4th, I have m, and there's no m. So since they don't all have an m, they do not all have it in common. So your GCF would just be 2 for that one. So remember, if they don't all have it, you can't take it out. And then you would just divide it out. So that would just be negative 10m to the 4th plus 7m plus 5. And that's what your final answer will look like for a GCF problem. You're taking out the common factor, and then whatever's left is in parentheses. So you guys, we'll try another few in a minute. See what you get. Remember, there's one there. Number 13 has like 2 variables. Just do one thing at a time. Do they have x in common? Do they have y in common? You gotta go from there. Nothing too crazy. So then the most recent thing we've been doing is distributing, which is just multiplying. So I'm gonna do 14 and 20. I'm just picking random ones. I'm just picking random evens because you guys are gonna do odds. Alright. Basically everything in this section, numbers 14 to 21, are based on the concept of distributing. So this one I'm only distributing once, and then once again, if I have binomials or trinomials, you might have to distribute more. So I would take this outside term, and I'm going to multiply it by every term in this trinomial, so all 3. The biggest mistake I see, once again for this, is when you're multiplying, you forget that k has a first power. Same thing here, k has a first power, so always put those in first so you don't forget, and then multiply. Now when I multiply, I'm multiplying coefficients, so that gives me 28. I'm adding exponents, so you only change the exponent with multiplication. Same thing here, that would give me minus 4. Remember, k times k would give me k squared, because they're both to the first power. And then plus 20, and that would just be k, because there's nothing to combine with that. So once again, the nice thing about this is like, well, I know how to add, I know how to subtract, I know how to multiply, I know how to divide. And I can kind of do it. It's not too terrible. It's just those little things that kind of add up. So just be careful. Things to the first power, make sure you put a 1. All right, I'm going to do 20, and then I'm going to have you guys try a few. So we talked about that. I guess it was yesterday. Man, that seems like so long ago that we talked about this. But we said, I can't just do properties of exponents because there's a minus sign. We have a binomial. So we have to think about what the concept says. The concept says, if I have 3v minus 1 squared, that means I have 3v minus 1 times itself. So just be careful with that setup. And then once I have that, I'm gonna distribute. So this brings in the distributing concept. It's just, since this first thing is a binomial, we'll have to distribute twice. So I start with the first term. And I distribute it. Remember, there's ones here as exponents. Because 3v times 3v is 9v squared. 3v times -1 is -3v. And then once I've done that, I just take my second term and I distribute that. I get -3v plus 1, exciting stuff. And then always make sure in the end, is there anything else I can do to make this in standard form or combine like terms? Heck yes, I can combine those v's. And I'd get 9v squared minus 6v plus 1. That'd be final. So the other ones were kind of set up similar, so you get the same idea. So that's kind of the idea. Once again, add, subtract, multiply, divide, we can do that. It's just now we're adding some variables in, some polynomials. So that might make it a little bit different, but